services to go through. So I'm going to touch on VPC sharing. I'm going to talk about VPC endpoints, and finally about Amazon Global Accelerator. So let's start with VPC sharing. And VPC sharing is changing the model of how you organize your VPCs. So before VPC sharing, when you created a VPC, it had to belong to an AWS account, which is a management boundary, and all the services you would deploy into that VPC would have to belong to the same account. With VPC sharing, we're changing that model. So you now have the concept of the owner account, and maybe this is an AWS account owned by your networking team or your infrastructure team. And they would build all the networking constructs. They would create the VPC, create the side-on-the-side arrange, create the subnets, set up all the routing, network access control lists, set up all the route tables and connectivity to other environments, exactly the same way as you would with a regular VPC, but it's controlled by that networking or infrastructure team. The big difference here is those subnets inside a VPC can be shared with other AWS accounts. So maybe now a web development team has their own AWS account, and they can deploy resources, EC2 instances for example, into a subnet that's been shared with them. And they have full control over that resource, and they can create security groups around their own resource, but they cannot make any changes to the resources that were created by the owner of the VPC. So for example, they can't make updates to the routing table or change network access control lists. And you can share those subnets with multiple accounts. So maybe another account is maintaining a database and they're creating an RDS service. They can put it in another subnet, and maybe there's some application teams that are building their applications, deploying them into those subnets. None of those teams can touch each other's resources. They always manage their own resources. But from a networking point of view, if they open up the security groups, they can now communicate with each other. So why would you use VPC sharing? So first of all, you can save on your IPv4 addresses. If you're running out of IPv4 addresses and you can create one bigger VPC and put more resources into it, you're going to utilize your addresses more efficiently. And if you have less VPCs, it actually means less interconnectivity. You won't have to create as many peerings or transit gateway connections or connections back to on-premise. And you have that nice separation of duties where the owner creates the VPC and participants cannot change it. They can't accidentally or on purpose add an internet gateway to establish internet connectivity, for example. And finally, everyone is still billed for the resources they create. So, and if it so happens that the resources live in the same availability zone, then the traffic within the same availability zone is free of charge. Okay. So I mentioned earlier that we have these services that live outside of your VPC on the public AWS address space. And we know now that we can use Direct Connect, the public virtual interface, to access those resources from on-premise. But what about accessing them from within your VPC? You can do that through an internet gateway, but maybe you don't want to deploy an internet gateway to your VPC. So for that, we have different types of endpoints. And we'll start off with gateway endpoints. And these endpoints are used purely for S3 and DynamoDB, only for those two services. So here we have an example of a VPC communicating with an S3 bucket using the internet gateway. But in our scenario, we don't want to use an internet gateway, we don't want to use any public IP addresses, but we still want to be able to reach S3. We can establish a VPC gateway endpoint to S3 and then navigate all the traffic through an update in the routing table through that endpoint to privately communicate with S3 without any usage of public IP addresses. Another type of endpoint we have are interface endpoints. And these endpoints are now used by all the other services that are becoming available inside your VPC. So an example here is AWS Services API. So if you want to connect to that service, you can use an interface endpoint. And instead of doing any routing, we will make it look as if that service lives inside of your VPC, and it will use IP addresses from within your VPC range. So when your EC2 instances are connecting to that service, they will be connecting to a local IP address, and behind the scenes privately transported to the actual service they want to communicate with. So this mechanism allows you to also override the public domain name for the service, so only inside your VPC it will resolve to your private IP addresses. And a lot of customers and partners are using this for sharing their services themselves. So you can do it yourself as well. And the technology powering VPC endpoints, VPC interface endpoints, is private link. So we allow you to use that technology yourself to share your own services with thousands of other VPCs. So in this example, we have a service, maybe this is a HTTPS service, and you want to share that service with a lot of other VPCs, maybe some third parties. So you need to put it behind a network load balancer, and then make it available as an endpoint service, so that other VPCs can subscribe to that service and create endpoints representing your service in their VPCs. So again, they will be connecting to a local IP address, representing your service, and be transported to your service hosted in another VPC. And using private link allows us to only expose a specific service port that we're connecting to. So if it's HTTPS, it will be just 443. Connectivity is only allowed in one direction, so only consumers can connect to the service. The service provider VPC cannot connect to the consumer VPCs. And finally, in this scenario, you no longer need to care about IP addresses anymore. So those IP addresses in the VPCs can overlap, and you can still expose the service this way. Okay. Finally, a service that's focusing on something slightly different. So now we have an application on AWS that's already publicly facing, maybe in a region in Europe. And we have users from outside of that environment that want to connect publicly to our application. And we want to make sure that the experience for those users is as good as possible. So Amazon Global Accelerator is a network-based service that you deploy between your users on the internet and the application that's internet-facing, hosted on AWS, that allows you to optimize the experience for those users. And it can cover any type of application running on TCP or UDP. Why does it matter? So if we have an application that's facing the internet today, and we have users connecting from all around the world, they'll be traversing a lot of different networks, their ISP and some other carriers, and there's a potential for these paths to be impacted by some, let's call them internet weather conditions. So you don't control the end-to-end experience of that user. When you deploy a global accelerator, you're able to bring the traffic from your users onto the AWS backbone as close as possible to where your remote users are. And then from there, the traffic will use the uncongested managed AWS backbone to the actual service running in an AWS region. Okay.